Differences in the severity of disturbances for ecosystems can cause differences in how those ecosystems respond. And we need to think about the severity in which factors the disturbance affects. The most severe disturbances, those that remove a lot of biomass and a lot of the products of ecosystem development, cause what we term to be primary succession. So these are just the most severe disturbances. For example, when we have volcanoes that erupt, the ash and lava that is produced has relatively no biotic products within it. You're starting from bare substrate. And ecosystem development starts from scratch for all intents and purposes. This is a picture of Mount St. Helens not long after it erupted in 1980. So the eruption date was May 18th, 1980, and a lot of the lava flows and the volcanic ash essentially generated new substrate for colonization, and there was little products that still remained from previous ecosystems. So now we're going to take a look at satellite photos of the region around Mount St. Helens. So this is 1979, a year before the eruption. This is a false color image, and anything red here has vegetation in it. And you can see there's individual clear cuts that occur, and that's a lighter red, and the darker red are intact forests. This area right here is all intact forest, and you can see a number of clear cuts on this side also. It's going to switch to visible color in a second, so everything that's red now is going to look green, but this is essentially what the area looked like pre-eruption in 1979. So there's 1979, and here's 1980, not long after the eruption. All of this area is lava flows and ash. So everything that's gray here really is a new substrate to be colonized. The forest had been obliterated and covered with ash, such that what you see here really has no products of the ecosystem. Now what we're going to look at over time is how this ecosystem developed and recolonization occurred. So there's 1980, and there's 1981, 2, 3, and in the margins here, so we're already at 1985, you can see some green starting to show. And that's as plants started to colonize and grow. 86, 87. So we're now 10 years after, and you can start to see skims of green on a large portion of the area that was denuded earlier. We're now 15 years after. We're now 20 years after, and you can see some really dark green areas of forest that had regrown almost completely. And then I'll let this go all the way to 2011. So there's 2011. And by now, 30 years after the eruption, there's still some bare areas that are there, but the rest of the area had regrown into forest. Now, it doesn't necessarily mean that this forest is the same as the intact forest that was not affected by the volcano, but still, what had happened is what we call primary succession, where we start over basically from scratch, and soils have to develop as well as vegetation. Most disturbances leave some soil organic matter in plants or plant propagules in place, so that even though we talk about primary succession, generally most disturbances are not going to start with a bare substrate that doesn't have any soil organic matter or plant propagules such as seeds that are there. And for most of the part, it's secondary succession that follows disturbances. So if we take a look at how most ecosystems respond and some of the trajectories that we have, we're really thinking about what we call secondary succession, where we still have organic matter that's going to be in the soils, and there might be a few plants still present, or if not, a lot of the seeds that allow that vegetation to regrow pretty quickly. So when we think about secondary succession, there's a whole suite of different disturbances. Wind throw is one of them. This is a picture where we had flatline winds in northern Minnesota that really just snapped off a large number of trees. but the soils are still in place. You can see there's still a lot of plants that are present, and you'll have recolonization and regrowth in the areas that have been hit by the disturbance earlier. When we think about resilience to disturbance and the subsequent successional trajectory, we need to think about the initial disturbance impact. So as far as forests are concerned, you might have biomass that's going up and leveling off, and then we need to know what that disturbance impact is like. I didn't draw that right. To think about what the recovery is going to be. And it's not just how much plant biomass was removed, but other things like nutrient availability and changes in soils. But also disturbance size is important too. So for any one area, you might lose almost all the biomass and then it recovers, but that's going to be in a matrix. And so you'll have a disturbance over here, but the rest of the area around it might be intact. And so that's going to affect colonization and dynamics within that area too. So the disturbance pattern, disturbance size is important, and the disturbance pattern on the landscape. So its intensity, its size, its pattern. And a more complex view of how disturbances work and ecosystems respond really takes a landscape perspective, and then just doesn't necessarily think about any one little patch, but that patch in a matrix of other systems also. So here's a relatively complicated diagram. You can read about it in your book, and this is 12.8, that essentially thinks about how different patches on the landscape interact with one another and impact the recovery or the resilience of systems that are being disturbed. Among the factors that are important for thinking about landscape level patterns when we think about disturbance, really it starts to do with colonization, for example. So a disturbed patch right here where all the plants are killed off, we need to think about colonization from surrounding patches to think about what the disturbance trajectory is going to be. So there's might be a seed bank or a seedling bank that's present in that area that could be used for growth of the vegetation, but also there's going to be colonization from adjacent areas. And the trajectory from one patch versus another is really going to depend on what's adjacent to this patch versus this patch. The last term we're going to discuss here is disturbance regime. And earlier we talked about regime shifts, and that's really not related here, but a disturbance regime really is thinking about the overall pattern of disturbances over time. So for example, for a given type of disturbance and severity of that disturbance, a disturbance regime is the frequency at which the ecosystem is disturbed and its timing. So on the frequency aspect of a disturbance regime, that we can have periodic forest fires that happen. And it's really just thinking about how long apart those different fires are going to happen. So in some places you might have annual fire, in other places you might have fires that occur every 100 years, and that's part of the disturbance regime. Just a way of characterizing a general pattern of disturbances that's going to occur.